All right, here we go. We're not going to get real deep into this, but we'll at least get started. Okay, today, now we're changing to scientific models, in particular logistical models, and understand what that happens, at least on the backside. So we get this new formula here when we talk about science. And again, the only difference is scientists and economics people don't talk to each other. Okay, our formula that we are familiar with is y equals just playing. Oh my goodness. A equals P-E-R-T, our PERT formula. They gave it to us like this. The other way they could write it is y equals A-E-K-T. That's the formula that I see a little bit more often. Same difference. Okay, they're exactly the same. Okay, so A sub 0 is right here, the initial. That's what the little sub 0 means. That is going to be in the same place as the P in our other formula. So what do you think that value represents? It's our initial. It's our starting amount. It's our initial amount. It's our principal. It's our starting amount. It doesn't matter. Okay, no matter what the formula looks like, whatever's there in front of your E, that's your starting amount. Our K is right here. It's with our T. It's in the same place as R. So what do you think that's going to represent? It's our rate, and it needs to be written as a decimal. So rate as a decimal. Now, we do have two different lines here. When K is greater than 0, that's a growth rate. Or if it's less than 0, it's going to be a decay rate. So basically, is the amount of stuff going up or going down? So far, when we dealt with financial models, it was always a growth rate because interest rate is going to grow your money over time. It's not going to make it go down. It's not going to decay. And then T represents time. We're only going to do one type of problem today, and that is a half-life problem. Have you done half-life before? Show our hands, raise your hand if you've seen. All right, good. That's different. That's crazy. My last class, I would say maybe only a third of them said they'd done half-life before. And it seems like you guys are substantially higher than that. Let me just give you a quick reminder what half-life is. So let's say you have some substance. Okay, you got 100 grams. The half-life is how long does it take for you to get half of that? Okay, and so this is a radioactive substance. Some of the particles, I forget what it is. Is it electrons? Sure. The electrons, the nucleus is unstable. It's losing mass. Okay, and it's saying how long does it take you to get just 50 grams in the end? Oh yeah, that doesn't work as well as I wanted it to. But 50, that's what the half-life is. Okay. This is what we do all the time with like carbon dating. If you want to figure out how old a dinosaur bone is, they're going to estimate what the initial mass should be and how much it is now, and then use carbon dating to figure that out. Okay. This is radioactive material, and we're going to use that to help discover what's going on. So half-life is the time required for a quantity to reduce to half its initial value. The term is commonly used in nuclear physics to describe how quickly unstable atoms decay. So here we go. It says the half-life of radium is 1,690 years. If 10 grams are present now, how much will be present in 100 years? So when we do half-life, I always suggest you cutting your paper in half. Okay, half-life, cut your paper in half because there are two things you need to do here. Okay, first thing you got to do is figure out your rate. You got to figure out your K value. And then once we've figured out our K, we can go from there. So it's y equals AEKT. The first thing we're going to do is half-life. So looking at just that sentence really that talks about half-life is this guy right here. Half-life of radium is 1,690 years. What is something I know? The initial. What's our initial going to be? 10. You can do that. In fact, on this one, though, you don't even have to have the initial to be 10. Okay? But let's call it 10 just to make life easy. So if this is 10 and we're doing half-life, okay? So my time is going to be 1,690 years. After 1,690 years happen, how much am I going to have left over? 5, because it's half-life. That's the name of the problem. You're going to have half as much. This is the lifespan that it takes to get cut in half. And so whatever you start with 10 is going to be cut in half after 1,690. You don't have to use 10 here. You could use any amount you want to, because after 1,690 years, it's going to be cut in half. Okay, so if you want to make it easier on yourself, make it 2 and 1. Okay. If I wanted to solve this thing, I'm going to find the growth rate, or in this case, the decay rate. I'm trying to find K. What would I do first? Divide by 10, divide by 10. It's going to get you 0.5. No matter what number you started with, you're then going to have 0.5 after you divide. 1690K. I want to get K by itself. What next? Natural log on both sides. The natural log and the E are going to cancel. So in my calculator, I'm going to take the natural log of 0.5. But what else do I need to do with that natural log of 0.5? Divide by 1690, because that K is going to come down, and it's going to be 1690K. I'm going to divide by 1690. K is going to be equal to, so I'm taking that divided by 1690. I get negative 0.4101. E to the negative fourth. Kids get worried about that number. Okay. 4.101 e to the negative fourth. Remember, that is scientific notation. That little e to the negative fourth just means you are moving the decimal 4 places to the left. 1, 2, 3, 4. 0, 0, 0, 4, 1, 0, 0, whatever. That's my decimal. Okay. I don't really need to write it down anyways. I'm going to keep it in my calculator. Okay. But that's what's happening here. That's my K. It's this negative 0.0004. I'm not actually rounding it. I'm just writing it down so you know where it's coming from. But I'm going to leave that in my calculator. That is my K. Once you find your K, now you're going to be able to actually solve the question. Okay, so let's go back to this. It's half-life. Y equals AEKT. 10 grams are present now. That's my starting amount. How much is going to be present in 1,000 years? I know what my K is now. It's this negative 0.004 number. I'm substituting that in for my growth rate. Does it make sense that that growth rate is negative? Talk with your neighbor and discuss why is that growth rate going to be negative. Jack, why is that K negative? It's getting smaller. It's a decay amount. It's getting less and less. My T is going to be 1690. Thumbs up if you think my answer at the end here is going to be bigger than 5. Thumbs down if you think your answer at the end is going to be less than 5. Talk with your neighbor and discuss how you know before you do any math that it's going to be bigger than 5. What? It is 1,000. I just wrote it down wrong. T is 1,000. I wrote it down wrong. My fault. Anybody want to explain how we know there's going to be more than 5 grams left? Max, what do you think? Yeah, we're only going 1,000 years. Okay, we said 1,690 years is going to cut it in half. So after 1,690 years, I had 5 grams. Well, if I'm only going in 1,000 years, that's not enough to get it cut in half. And so I know my amount's going to be bigger than 5. Okay, so just use your brain and understand what's happening. But I'm going to type that in now. So it's 10 E to the K. I'm just going to highlight that thing times T. And my T this time is 1,000. I type it in. I hit enter. I get 6.636. That's how many grams are going to be left after 1,000 years. After 1,600 years, I'd have 500. But since I only want 1,000, I've got 6.636 left. Questions there? Let's try it again. Half-life of a certain bizarre glowing substance is 50 weeks. How long would it take for 400 pounds to be reduced to 90 pounds? Don't worry that it's in weeks instead of years. It's fine. Just treat it in weeks. Everything will be fine. Again, you're doing half-life, so split your paper in half. Y equals AEKT. If they didn't give you your growth rate, find your growth rate first. In this case, your decay rate. And then once you've found that, plug in your K and use it to solve. Do it with your neighbor. Go. All right. So half-life is 50 weeks. How long would it take for 400 pounds to reduce to 90 pounds? So when we're starting this thing off, the first thing we want to do is find K. We want to find that K value. Okay. And I know if you've done this in a science class before, you might have gotten something different, but we're trying to manipulate this equation. So we're going to do the same thing, just in a longer fashion, maybe, or a different fashion. So what'd you plug in here? Ella, what'd you plug in to find your K? 1 and 2. Great. You could plug in 400 and 200. That totally works. Ella said she's just plugged in 2 to start, and she's going to end with 1 because it's just going to be half-life, which is a great idea. You don't know what K is, and your time is going to be 50. Great. Okay, so she set that thing up 1 and 2 just because it doesn't matter. If you did 400 and 200, the first thing you're going to do is divide by 2, and you're going to get a 1/2 no matter how you do it. She just picked easier numbers. 0.5 is equal to e to the 50k. Once I've done that, Sam M., what'd you do next? No, not yet. ln. First, we're going to take the natural log to get rid of the e, and then divide by 50. Good. So natural log of 0.5, and I'm going to take that and divide it by 50. I get negative 0.01386. And again, I'm not actually rounding it. I'm just writing it down so you can see it. Okay. That is my K. It should be negative because I'm getting smaller. Okay. I know that. Now it says, how long would it take for 400 pounds to be reduced to 90 pounds? What am I solving for on this one? Time. How long? So I'm starting with 400. I'm ending with 90. My K is going to be this negative 0.01386 number. And then T. So in my calculator, I'm taking 90. Let me clear this out. 90 divided by 400. So I get 0.225 equals e to the negative 0.01386t. Then what, Abby? ln, good. We're going to take the natural log on both sides. That's going to cancel. So the natural log of that number right there. And then I'm going to take that number and I'm going to divide it by our K value. And I just deleted all those. So, it's that guy right there. Take it and divide by that. That is going to be my time, 107.600. T equals 107.600 years. And again, that number should make sense because after 50, or I'm sorry, that's not years, that's weeks. After 50 weeks, I get cut in half, so then I'd be 200. After 50 more weeks, I'd get cut in half, that'd be 100. And I'm trying to get to 90, so it's going to be a little bit more than 100 weeks. Okay, using your brain to kind of think through those, I think, is an important concept. Questions on something we did today? All we talked about was half-life there.